Chapter 2 is an introduction to TI's integrated development environment called Code Composer Studio. If you're familiar with Code Composer Studio and the Eclipse environment, you can consider skipping to Lab 2 for a quick refresher. Development tools like Code Composer and evaluation products like the LaunchPad board are just a part of TI's support ecosystem for its processors. Runtime software support includes Tivaware for C-Series, as well as TI's RTOS called SysBIOS. There is a rich community of support for TI's products through the forums, E2E pages, wikis, in-person, and online training. Tiva C-Series microcontrollers are supported by 3 different integrated development environments: IAR Systems Embedded Workbench, ARM Keil Microvision, and Texas Instruments Code Composer Studio. IAR and Keil's evaluation licenses are code size limited. Code Composer Studio is full function, but it is on-board emulation limited. When connected to the LaunchPad board, it is fully functional and free. Only if you connect Code Composer to a target board will you need to buy it. Compiler technology is critical to achieving code size and speed goals. TI's compiler has been developed in-house over many years. For the debugger and editor interface, Code Composer uses Eclipse. Eclipse is an open source tool that is quite popular at this time, primarily because of many third-party tools available as add-ins. The prices for upgrading to the full versions are shown in the chart. Code Composer Studio is $445 US for the downloaded version. If you want the CD, it's another $50 US. All of these companies offer JTAG debuggers, and there are also quite a few third-party debuggers for sale as well. TI's runtime software support includes TI wares and TI RTOS. TI wares like Tivaware minimize programming complexity with low-level driver libraries and peripheral driver libraries. They can be used with multiple development environments. TI's RTOS is comprised of an optimized real-time kernel called SysBIOS. SysBIOS is optimized for TI devices and includes scheduling, memory management, instrumentation, and is fully compatible with Tivaware. Programming of USB and Ethernet ports is made easier with file systems and stacks. Code Composer Studio is an integrated development environment. This means that it contains the tools necessary to create, compile, and debug software on your design. CCS is based on the open source Eclipse platform and is quite flexible and expandable. A normal development environment flow would be to create C source files using the editor on the left. These files would then be compiled to create assembly files, which are then assembled into relocatable object files. These object files, along with any libraries that you may include, are linked into an output file using the guidance provided by the command file. The command file contains a list of all memories on the part and what types of software should be placed within them. Finally, the debugger on the right uses the target configuration file and GEL startup files to initialize and load your software onto your target device. Code Composer contains a simulator on which you can test your software. Evaluation boards like the LaunchPad contain their own built-in emulator to connect CCS to the hardware. For target boards that do not contain an emulator, like any normal customer design, a standalone emulator must be provided. There are many available from TI and other third parties. In Eclipse, designs are organized into workspaces and projects. This view in Code Composer Studio is of the Project Explorer window. When you start Code Composer, it will ask you what workspace you will be working in. The contents of that workspace will be shown in the Project Explorer window. You can have many projects within the workspace and open and close them at will. The Project Explorer will show you the contents of the workspace and of the projects. This is a conceptual view of workspaces and projects. Physically, both of these are merely folders on your computer. The Workspace folder contains Code Composer settings and preferences. Projects can either reside inside the Workspace folder or can be linked from elsewhere. When you delete a linked project using Project Explorer, only the link will be deleted. When you delete a copied project using Project Explorer, the actual project will be deleted. Settings made at the Workspace level affect all projects in the Workspace. The Project folder contains the Build and Tools settings for each project. Again, files can be linked to or reside inside the project folder. Deleting a linked file within Project Explorer only deletes the file. A project can contain source files, which include code and data, header files for declarations, library files, and other settings. When you add files to your projects, you can either copy or link them. Source files are typically copied, while library files are typically linked or referenced. To add a file to your project, just right-click on the project name and select Add Files. You can then select the file or files that you want to add to the project. In the final step, you decide whether to copy or link the files. Copying will simply copy the file from its original location to the project folder. Linking references the source file in its original folder. You can select the link type relative to a variable. It's important to make your projects portable. Portable projects simplify the sharing of your work with colleagues or support staff. It makes it easier to relocate your project, if desired, and when software libraries are updated, it's a simple change to link to them. In the top figure, you can see that copied files are not a problem since they will move along with the project folder. Linked files, on the other hand, may be an issue since they are located outside the project folder and are referenced by either an absolute or relative path. Note the path variable in the bottom figure for the relative paths. This is specified for every linked file. Two different kinds of variables are used: path and build. Path variables are used by CCS to store the base path for relative linked files. So the project loc variable is set to the location of your project and can be used as a reference point for any other relative paths. Build variables are used by CCS to store the base path for build libraries or files. CG tool root is set to the path for the code generation tools, which are the compiler and the linker. This is used to find your header files and any other object libraries. These two variables are automatically defined when you create a new project and when you install Code Composer with the build tools. Tivaware and any additional support libraries will require you to create some new variables yourself. You could use the predefined variables to link to all of your resources, and this will create a nearly portable project. Since the links in your projects are relative to these locations, if you move or copy your project, you'll have to put them at the same folder level in the file system. Defining a link and build variable for the Tivaware location will give us a relative path that does not depend on the location of the project. This is more portable. Also, when the next version of Tivaware arrives, we only need to change these variables, which is easier than creating new relative links. On the CCS menu bar under Project, Properties, expand the Resource category and click on Linked Resources. You'll see a tab for path variables. Click New and add your new path variable. Again, in the Properties, click on the Build category and then click on the Variables tab. Click New to add a new build variable. In the lab, we'll add a path variable and build variable called Tivaware Install that will point to the latest Tivaware release. Note that you can define variables to be part of your project, or you can define variables that would be part of your workspace and be a part of all the projects that are within it. Code Composer has two predefined build configurations: debug and release. The debug configuration is great for, as the name implies, debugging. It includes the symbol tables and no optimization in the load. The release configuration is better for performance, but contains no symbol tables and the code has been optimized. This can make debugging difficult or impossible. You can create your own custom build configurations by right-clicking on the project and selecting Properties. Then click Processor Options or any of the other categories that you want to change. For additional training on Code Composer Studio, look to the menu bar for tutorials and the wiki page shown for more detailed training. In this workshop, we'll barely scratch the surface of Code Composer's abilities. These are some of the middleware and protocol partners who've joined the Tiva C-Series effort. All of these involve RTOS, or real-time operating system solutions. Most offer Ethernet, communication, and file operation stacks as well. Some offer advanced GUI programming support. In Lab 2, you'll start using Code Composer Studio. Don't get bogged down trying to understand the code. You'll get to that in the next lab. Here, just concentrate on the tool itself.